Sir, back to that DFT example on the last page. I see the math how we got 1 for x of 0, but then if this signal would have been like x of 0 1, but then x of 1 something else, would you just add like
Yeah, let's do it.
answer where we have all ones? Would that just look like?
Yeah, let's do a fast one of that.
Sure.
Let's let x of n equal this. Then x of k is always equal to the summation of x of little n e to the minus j 2 pi k little n over capital N. So for this particular example, we'll have to solve it repeatedly. We'll have to firstly find what is x of 0. So to do that, we do the summation from over all of x of n
1
of e to the minus j 2 pi, now we're doing 0, little n over capital N. Since this is e to the 0, that's the same thing as saying the summation from n equals 0 to capital N of x of n, since all of this goes to 1. And for this particular example, that would be 1 plus 2 equals 3. Now we can solve for x of capital 1. So that would be the summation from n equals 0 to capital N minus 1 of our x of n times e to the minus j 2 pi. K is 1 here, little n over capital N. So that would be x of 0 times e to the, when we plug in n for little n for 0, we'll get e to the 0 plus x of 1 times e to the minus j 2 pi over capital N, where capital N is equal to 2. So this would be equal to 1 plus 2 times e to the minus j pi. And what does e to the minus j pi look like? Well, let's look at the whole thing. What is 2 e to the minus j pi like? That looks like a circle. It's on the unit circle. It's on a circle of radius 2. Here's the real part. Here's the imaginary part. And what I've drawn here is 2e to the minus, what I've drawn here is 2e to the j omega. So our angle here is minus pi. So minus pi brings us out to this point. And so that has a value of
-2.
-2. And so the whole sequence now is just x of k is just that sequence of 3, -1. Does that answer your question?
Yes, sir. Thank you.
Sure. Any others?
Sir, can you go back to the last page real quick?
Sure.
So for your, where you have n equals 5 circled,
Mm-hmm.
to the down and right of that, where it's the stem plot of x of n,
That's right.
what, I think those are in gray, the indices above the values. What are those?
That was because I misunderstood what Fawaz was asking me in his question about. He wanted to know why over here. I was counting how many samples there are. And I was verifying that there are indeed 5 samples in this, which corresponds to the fact that it's a finite length sequence of n equals 5. The indices are down here, 0 through 4.
All right, I was just making sure. So that's just showing that when you're counting samples, you count
from 0.
1. And so the n equals 5 on that basically says like, this is how many samples we have, and this is the number of samples we care about. Like you could pad that with zeros, but we only care about the first 5.
That's correct. That's exactly correct. Which for the DTFT makes no difference, but for the DFT it does, because by saying our input finite length sequence is 5 long, we're saying our output DFT will also be 5 long. And if you computed the length 6 DFT, the first 5 numbers wouldn't match the first 5 numbers of the n equals 5 DFT, because you're sampling it at you're sampling the DTFT at completely different points.